Hello, students. This is a review of finding area of quadrilaterals. We are mostly off book this week. What is a quadrilateral? It's a shape. A better word for shape in this case is going to be a polygon with 4 sides. A polygon is, you can look it up in Google. Actually, we looked it up in class and there were a lot of bad definitions. Polygon is actually a kind of complicated. If you want to be very precise, there's 3 separate pieces to the definition. Here are some of the parts. A polygon is a closed plane figure made of line segments that intersect at exactly 2 points. Okay, so that's kind of an interesting definition. We've talked about a lot of shapes. What are the shapes we've talked about so far? We've talked about no dimensional shapes, 1-dimensional, 2-dimensional, and polygons and quadrilaterals. Those are all on this flat surface, the plane. We've talked about points. We've talked about lines. We've talked about planes. We've talked about line segments. We've talked about angles. We've talked about rays. We've talked about triangles. I'm probably missing one. Of all of these, the only polygon is a triangle. A triangle you can draw on a plane. Quad means 4, so quadrilateral has 4 sides. Okay, you put 4 sides together, 1, 2, 3, 4, you get a quadrilateral. Okay, if you put 4 sides but they don't close, that's not a quadrilateral. If you put 4 sides but they kind of like cross over each other, that's not a quadrilateral. Okay, so it has to be closed and it has to have 4 sides. So mostly like this, assuming these actually intersected each other. The way we name quadrilaterals is with the vertices. So this could be quadrilateral Q, U, A, D. Okay, we would name it by the 4 letters at the corners. And the order would matter. You could call this quadrilateral QUAD, but you could not call it quadrilateral QADU. Okay, if I point to those letters, I'm going to be drawing the quadrilateral. There are lots of different types of quadrilaterals. We're going to start with talking about squares and rectangles. Triangles, what's that doing in there? Oh, well, we'll find out. So we'll start with the basics. So what is a square? A square is a quadrilateral that's special. It's actually the most special type of quadrilateral. It has 4, how do we say equal in geometry class? That's right, congruent sides and 4 right angles. Okay, that's one definition. Another definition is it is a rectangle with 4 congruent sides. That's another definition of a square because squares are rectangles. Another definition is it's a parallelogram with 4 right angles and 4 congruent sides. Basically, for something to be a square, it has to have the same mark on all 4 sides or numbers that tell you that they're the same, and they have to have right angles in the corners. So if a figure is marked like this, then you are allowed to say that this is a square. And this, if you just saw a picture look like this you could not assume is a square, even though it totally looks like a square. Okay, they might be trying to trick you. Maybe this is a 16 and this is 16.001. Okay, you wouldn't know that these aren't the same unless it was marked. So you cannot assume that it's a square unless you have verified markings. Again, the way we label it, this would be square ABCD. That is how we would talk about square ABC. Okay, that means I want to name that shape. All right. So we're talking about area, and I'm going to assume that all the figures here are squares, even though I didn't mark them. But I can look on the graph paper and I can count it. So this square has a side of 1 and another side of 1, if I'm just counting like the number of squares. So the area of this square is 1. Okay, here's a trick question. What's the area of this square? How many squares is it? It's 1 square. What's the area of this square? 1. Area is the number of squares that cover a shape. So how many squares cover this square? 1. What's the area of this? 1. Okay, so it's kind of an interesting thought experiment. Every square that I give you has an area of 1 square. It just depends on what size square it is. Okay, now this would probably not get you very far. Instead, while it is true that every area has an area of 1 square, on this graph paper, the unit has been defined for us. So this is what we call 1 square unit. And I don't really know how big this paper is. Okay, so I'm going to call this 1 square unit. That means the area of this square is also 1 square unit. Area is the number of squares that, you could write it like that, or you could write 1 unit squared like that. That's another way to write it. Units times units is units squared. That says 1 square unit. Okay, this one, if we're counting these as the unit, okay, then how many squares fit in this square? Well, we could kind of draw on top and we could see, aha, this square has a side of 2, and this has a side of 2, okay, and this has a side of 2, so this is definitely a square. And how many squares fit inside of it? Well, 2 squared is 4, so this answer is 4 units squared. 2 units times 2 units is 4. These are cool numbers. It's good to know your perfect squares. And how about this one? 3 squared, 3 times 3 is 9. And this one? Good, 16. Okay, and let's count it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is a square with the sides are all 5. Okay, and to find the number of units inside, we would multiply 2 of the sides together. So there are 25 squares inside of there. And this one is 36. Okay, these numbers are just kind of good to know. Square numbers are really interesting to us. But how do I want you to show work? So here's a picture. We are going to assume that it's a square. I can actually count it to verify. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units along the bottom. And I counted it earlier. Trust me, it's 15 units along the side. Okay. So there's 2 formulas you could use for area of a square. You can use the area of a square is the base times the height. Actually, there's 3. You could use the area of a square is the length times the width. Okay. You could also use area of a square. Yeah, I usually draw the little picture is the side squared. all three of those are good equations to use for areas of squares. I'm going to use this one, and this is the way I want you to show work on the 10 questions I assigned. So area of a square is 15 units times 15 units. Okay. And then notice how I put the freaking units in. Don't be lazy and just say 15 times 15. No, you only have 10 problems. Take your time, do it right. Anyone know 15 times 15? Good, 225. Okay, and what is units times units? What is a linear unit times another linear unit? It's a square unit. Units times units is units squared. And then you put a box around it like that. This is how I want to see work. Okay, the other way you could do this problem is you could do the area of the square is, notice how I'm using parentheses when I substitute. Okay, that's the correct way. And then for this one, you could do 15 squared and units squared. This is one way to show work on this. 15 times 15, that's what 15 squared is 225 units squared. Just another way to show work. This says the area of the square is 225 units squared. All right, so squares are the easiest, but I still want you to show work. And I want you to make sure you're including units here and here. All right, what is a triangle? Well, we spent a lot of time with triangles, but one way I want you to think of a triangle is, here's a shape. That looks like a rectangle type shape, okay? How much is the triangle of the rectangle? Anyway, that's half. Okay, so let's play with that. We've done a lot with triangles so far. We're going to do a lot more with triangles. Right now, we're going to spend some time remembering how to do area of a triangle. So all three of these, do you know what types of triangles these are? These are right triangles. And that's classifying by the angles. What about the sides? Do these look special? Yep. Okay, these are right isosceles triangles. And they're kind of special. Because if I used my imagination a little bit, I could do a reflection, okay, across some line here. And I could draw the rest of the square. So I could fill in the rest of this stuff. Yeah. And we just practiced doing areas of squares. So this is actually almost the same thing. Okay, yes, these are right angles. Yes, I can count and actually find out the number of squares. Yes, that is a right angle. Okay, so if I'm going to find the area of these triangles, I'm not going to use area as base times height. That doesn't make any sense. Area is not always base times height. It depends what shape you have. So in this case, it's definitely not base times height. The area of a triangle is half the base times the height. Okay, so for this one, I'm going to count 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and these are units, and we're going to be including units. Does anyone know? Did I count that right? 1, 2, 3, 4, 5. Yeah, I did. Okay, so the question is, how long is that? If I wanted to find perimeter, I would have to find that. I know how long that is because I've done this a lot. But let's pretend we're not doing perimeter for a second. We're going to do very carefully substitute with parentheses. This is just good math practice. Be neat, be organized, line up your equal signs. 4, 5, 6. That's unfortunate. I just realized I messed up in the earlier lesson. So this is 49, half of 49, which is like half of 50, so it's 24.5. And then units times units is units squared. That's because when we're finding area, we're finding how many squares cover this. So I could count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all these halves add up to 24.5 squares inside this square. Okay, same idea here and here, except what about this one? So this is base times height here. It just happens to be on a different side. So even though it's flipped around, you have to make sure you know which one's the base. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. Okay, so this is a 13 units by 13. So when I do this problem, I would do half, the area of the triangle is half 13 units times 13 units. Okay, what about this one though? Where's the height? This, you can't count on the diagonal. So for this one, you actually have to do some more work. So I'm going to count the one that I can count, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this diagonal of this rectangle is 12 units. Okay, what you have to do for this one is you have to drop the perpendicular. Okay, so the height of this triangle is actually inside the triangle. Well, that's kind of interesting. So we need to find that before we do this problem. It's 1, 2, 3, 4, 5, 6. 6 units. So when I do the area of this triangle, I'm still going to do half the base times the height. In this one, it's going to be half 12 units for the base, and the height is, when you look for height, you're looking for where the right angle is. Okay, right angle to the base. Well, it's going to be 6 units. I'm going to do half of 12 is 6. I just multiplied half times 12. And then I'm going to multiply by 6 units. The area of this bottom triangle here is 36 units squared. Excuse me. All right, what about an equilateral triangle? That's kind of fun. The hard thing about an equilateral triangle is that there's no right angles. So you can see that this would be a really interesting and challenging problem. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. We could call that 9 units. Okay, how would you find, let's assume that this is an equilateral. How would you find this distance? And I'm going to tell you right now, it's not 9. And it's not even 1, 2, 3, 4, 5, 6, and a little bit. There is a way to find it, but it's not super easy. Anyway, this is a good challenge problem. Let's look at this one. This one they made a little easier for you because they gave you what we call the altitude or the height. The height, you always want to look where that right angle is. Now, which of these 14 is the base? This one is the base. You want to look at where the right angle is hitting one of the sides of the triangle. That's your clue. Even though it's sitting on this one, this we don't need unless we're finding perimeter. If we were finding perimeter, we would add 14, 14, and 14. But if we're finding area of this triangle, this is the base and this is the height. So the area of a triangle is half the base times the height. Do you think you're supposed to write that every time? Yes, write it every time. This is not going to hurt you. Okay. And then we plug stuff in. So we do half. What's the base? 14 meters. What's the height? 12.1 meters. Can you use a calculator? Yes, I don't care about that. Half of 14 is 7. So this is 7 meters times 12.1 meters. Okay, I'm going to use my calculator. 7 times 12.1. Come on now. 7 times 12.1. 84.7. What 84.7 meters times meters gets you meters squared. It's a very large triangle. Okay. Too much information. They're trying to trick you. Is 11 the base or is 16 the base? (16) is the base. Okay, that's just there to try to trick you. So the area of this funny obtuse triangle would be half the base times the height. Area of this triangle is half 16 yards times 6 yards is the distance between the base and the opposite vertice. This is called an altitude or the height. Okay, half of 16 is 8. So 8 yards times 6 yards, and that's going to be 48 yards squared. And notice equal signs lined up, writing formulas, using parentheses when I substitute. Okay, boxing my answer, having units in my work and in my answer. That is what I want work to look like. And these are also weird obtuse triangles. They could have given you this number, right? But then you would need to know that. So with these obtuse triangles, and when they give you the altitudes or the heights outside the triangles, you just have to pay attention. So the altitude, the height is hitting this side essentially. So this is going to be the base, and that's going to be the height. The 19 we don't need. Okay, and this one, what's the base? 3 is the base, and the 2.8 is the height. They get a little confusing when they spin them around, and it's harder to see kind of where the rectangles are and where they came from. What kind of triangles are these? These are right scalene triangles. Okay. If I put this right scalene triangle next to another one like that, if I do essentially a rotation, it's not a reflection. A reflection would look different. But if I do a rotation around maybe that point there, and I put them next to each other, what shape do I make when I put two congruent triangles next to each other? I just gave it away. Okay, good. We get a rectangle. So what is a rectangle? A rectangle is a quadrilateral with 4 right angles. 4 rectangles. Okay, so the word rectangle actually came from right angles. Right angles. That's where the word rectangle came from originally. 4 right angles. Right angles makes a rectangle. If you're looking for a rectangle, you got to look for the right angles. Rectangles are, whoa, that didn't work. They're parallelograms, so these sides and these sides are congruent, those pairs of sides. Rectangles are not all squares, but all squares are rectangles. That's always a fun one to put on tests. So how do I find the area of a rectangle? Well, I just count how many squares are inside of it. Okay, so I could, fill all this in. Wow, that's a lot of lines, Miss Bliss. Yeah, well, there's a lot of squares that fit inside these rectangles. Wow, I should really use a straight line, but I didn't. Okay, basically, if those were perfect squares and I counted them all up, how many would there be? That's area. This is 1, 2, 3, 4, 5 units. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units. And if you had some time, you could count all of these squares and you would find out that the area of this rectangle is base times the height. The other formula you could use is length times width. That's a little bit more elementary school. Okay, and here's how I want you to show work. The base and the height, I don't know, it's hard. In a rectangle, it doesn't matter. I could say for this one, it looks like the 12 is the base because it's kind of sitting that way, but it don't matter. It doesn't matter. Okay, and then that's 12 times 5 is 60, and 60 units times units is units squared. You don't believe me, you can stop the tape and count all the squares and see if there's 60 in there. Okay, there will be. All right, what about this rectangle? Let's call it rectangle QRST. Okay, the area of rectangle QRST is, I actually did that wrong. I don't like that. So you should always start with the general formula. So the area of any rectangle, I usually just draw a little picture of the rectangle, is base times height. We could do length times width. The area of this rectangle, QRST, this is one way you could show work, is, what's the base? 1, 2, 3, 4, 5, 5 units. Huh? What's the height? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units. My goodness. Are these the same? Are they congruent? Same size, same shape? Is one rotated 90 degrees? Yes. Okay. And my point exactly is that the order doesn't matter, but the area of rectangle QRST is 60. Units times units, units squared. This is how to show work. You can do this. Do a good job. It's easy, so spend time. For some of you, it's easy. So spend time working on your notation and including units. And that's it. Ooh, one more. Bonus. All right, we have too much information. We don't need that one. Okay, it's true that these are the same. It's true that these are the same. We didn't really get into perimeter at all, but for perimeter, I would add 10.2, 14.2, 10.2, and 14.2 for the perimeter. So let's just finish strong. The area of any rectangle is base times height. The area of this rectangle is 10.2 centimeters times 14.2 centimeters. And I just randomly switched them. Maybe it would make more sense to put 14.2 as the base, but I didn't. And then I have a handy dandy calculator right here, 10.2 times 14.2, 144.84 centimeters times centimeters is centimeters squared. That's how you do these problems. Be good, work hard, keep learning.